Alright, today we're going to be looking and starting our unit on functions. By the end of this lesson, you want to be able to identify functions and also find the domain and the range of relations and functions. To start, for warm-up, we're going to look at this graph, and I want you to think about a possible situation about a bucket of water for the graph. If you notice, we have the time that has passed, and then we're also comparing it to the height of the water in the bucket. So for example, we might say something like there's a bucket, it starts to rain, so we see an increase in the amount of water in the bucket, and then at a certain point somebody dumps the bucket out, and so then it goes to empty. So first, a relation is a set of ordered pairs that represent the relationship between data. And we can show relations using tables, graphs, mapping diagrams, or obviously as ordered pairs. So let's look at an example. In a scoring system with some track meets, for the first place you got 5 points, for second place you get 3, and for third place you get 2 points, and for fourth place you get 1 point. This scoring system is a relation, so it can be shown by its ordered pairs. And we can go ahead and write those. So for first place you got 5 points, second place you got 4, third place, except for it wasn't 4 points, second place you got 3 points, third place you get 2 points, and for fourth place you get 1 point. Let's look at an example of another relation. Here we have three ordered pairs, 1, 3, 2, 4, and 3, 5. Now we want to express them as a table, graph, and a mapping diagram. So our x-coordinate is always going to be our first coordinate. So for 1, 3, we would simply put those into our table. So we'd have 1 and 3, 2, 4, 3, and 5. And then if you look on our graph, these points are actually already graphed because we have 1, 3, 2, 4, and then 3, 5. Now for mapping diagram, we're going to put our x values 1, 2, and 3, and then our y values, which are 3, 4, and 5, and then we're simply going to draw an arrow between the x and the corresponding y. So it'll be 1 to 2, or 1 to 3, 2 to 4, and 3 to 5. So now let's look at another example. Here we have a relation with four ordered pairs, -2, 5, -1, 4, 1, 3, and 2, 4. We want to express this as a table, graph, and a mapping diagram. So to start with our table, we can even create our own just by drawing x and y. So I'm going to put my x values in, -2, -1, 1, and 2, and then I'm going to put them with their corresponding y. So we have 5, 4, 3, and 4. Now for a mapping diagram, we're going to do the same type of thing. So I have x and y. So we have -2, -1, 1, and 2. But now notice on our y values, so we have just 3, 4, and 5 because there's the 4 is repeated twice. So now I'm going to draw my arrow. -2 goes to 5, -1 goes to 4, +1 goes to 3, and +2 also goes to 4. And then lastly, we can graph this. We're going to go ahead and just draw in our own graph. If you have graphing paper, it's going to be most beneficial to you as you are doing your homework assignments. Okay, so now here I have -2, so I'm going to go back 2 and then up 5. And then I have -1, 4, and then 1, 3, and then 2, 4 again. Okay, so now that we've talked about relations, let's just increase our understanding and how they relate to what functions are. We're going to start with some definitions. First, the domain of a relation is the set of first coordinates or x values of the ordered pairs. And if the domain is the first coordinate, the range of a relation is the set of second coordinates or the y values of the ordered pairs. Why is this important to understand? Well, it increases our understanding of determining whether or not a relation is a function. A function is a special type of relation that pairs each domain value or your x with exactly one range value, which is also your y. In other words, the x values do not repeat, and I would make sure that you really get that down because that's the important piece here. However, the y values can repeat. Now we're going to look at how we can apply domain and range and what it means. So here we're going to give the domain and range of the relation, and we're going to tell whether the relation is a function and explain why. So here, if you look at our graph, we're looking at this. Our domain values are all x values from 1 through 5 inclusive because we have those filled in dots, and we see a solid line. So in other words, we can write this as an inequality where 1 is the smallest value and it's going to be less than or equal to x, which is less than or equal to 5 because 5 was our largest value that our x would have because we have the dots. Now the range values is the same type of thing, but now we're looking vertically. Here it's all y values from 3 through 4 inclusive. So our 3 is less than or equal to y, which is less than or equal to 4. The relationship is a function because none of the x values have more than one y value. So when you look at it, we don't see a couple of x coordinates that have y stacked on top of each other, like vertically. Alright, so now here we're going to give the domain and range of the relation, and again we're going to tell whether the relation is a function and explain. Now, because this isn't a solid line graph, they're just giving us simply ordered pairs. We're just going to look at, we're always going to assume that this is our x and this is our y. We're going to list our domain and range. So here our domain is going to be 6, 5, 2, and 1. Notice that they're inside brackets. That's the way that we would write that set notation. Our range is going to be just -4, -1, and 0. Now here, this relation is a function because if we look, each x value only has one arrow coming out of it. So even though there's two arrows going to 0, because each of the x values only has one arrow, it is a function because all the x values have only one y value. So now it's your turn, 6th graders. Go ahead and pause the video, and I want you to try this one out on your own. I want you to go ahead and give the domain and range of the relation and then determine whether a relation is in fact a function and explain why. So here our domain for our first one, I'm going to go ahead and write that in the brackets, is 3, 5, and 4, because we don't have to write anything that's repeated. And then our range is going to be -2, -1, 0, and 1. Now if it helps you at all by looking at mapping, we can go ahead and do that. So I have 3, 5, and 4. And we're going to map that, these are x values, to our y values, which are -2, -1, 0, and 1. Now I'm going to go ahead and map. So our first ordered pair is 3, -2. So I'm going to draw an arrow to -2. Our second one is 5, -1. Draw that arrow. Then we have 4, 0. And then lastly, 3, 1. So now this time when we look, because we see those two arrows coming out of 3, this is not a function because 3 has 2 y values assigned to it. Alright, so here's another opportunity for you to give the domain and range and tell whether it is a function. So here our domain is going to always be our first values, remember? So our domain is going to be -4, -8, 4, and 5. That was a really sad looking 5. And our range is just simply 2 and 1. Now here we're going to look, remember, just at our domain values and check 1 arrow, 1 arrow, 1 arrow, 1 arrow. So it is a function because each domain value only has one range value. Now let's look at an example of an actual graph. And here we want to tell whether the relation is a function and explain. Now when we look at this, it might be hard to tell because you're not seeing the ordered pairs, but we can actually use something called the vertical line test. And this says that if a vertical line is drawn through any part of a graph and it only touches the graph once, the graph is a function. So what do I mean by that? If I go ahead and I draw a vertical line, okay, and I'm going to take that line and I'm just going to drag it through. So you can think about doing this with your pencil and drag it through my image. So at any point here, so if I stop, like right here, you'll notice that it's touching the graph here and it's touching the graph here, which means at that point there are two y values for one assigned x value, because when we're looking at x values, they're all going to be the same lined up vertically. So this would not be a function because it doesn't pass the vertical line test. So it's that whole idea, once again, that we're seeing the same, or we're seeing two different y values for the same x value. So now these last two again are your turn. So why don't you go ahead and state the domain and range for each one and then state if it is a function. So here our first one, our domain is 8, -4, -6, and 1. Our range is going to be 2, 1, and 9. Okay, and if we look, because I didn't have to skip any of my x values, it is a function. Each domain has its own range value. Okay, on our next one, our domain is going to be 4, 3, and 2. Our range values are going to be -5, -4, and -3. But if we look here, we see those two arrows coming out of 2. So this one is not a function. 2 has 2 range values. Okay, so let me know if you have any questions on this. Otherwise, you can go ahead and get started on your homework.